Hello, everybody. Welcome to a Diabolical Developer talk. Who here has seen me speak before? Who has not? Oh, my apologies. My sincere apologies. Well, you're going to have fun. So for the people who have seen me speak before, it is your job to try and tell the people who have not whether I'm speaking the truth or whether I'm speaking lies. Best of luck. So my name is Martijn Verburg. These days I'm a principal group manager for Java at Microsoft. Yes, you heard that correct, Java at Microsoft. And what it really means is that I'm a manager of managers. Boo. So I'm not really a software engineer anymore, haven't been for quite some time, sadly. So all of these people I list here below, so Monica Beckwith, Kirk Pepperdine, work with me inside Microsoft. They're my principal lead engineers for JVM architecture and performance. Ben Evans is a principal engineer at Red Hat, and he was my former co-founder at JClarity before we got acquired. And Jason Clark is a good friend of mine from New Relic. And Ben, Jason, and myself have got out the Well-Grounded Java Developer 2nd edition coming out very soon. So that's my plug for the book. So it's due to all of them that we have all this great information and things. I'm really just presenting it on their behalf in some way. And I have a few of my own anecdotes and things from what I see at Microsoft. But if there are any errors, they are all mine. If there's any inaccuracies, it's because I'm a manager, not an engineer. All right, so this is what I'm going to cover for you today. I'm going to give you a little bit of context as to why we care about this topic, JVM ergonomics, at Microsoft in particular. There's a little bit of surprise there. I'm going to remind you about hardware resources because you all forget because you're just software engineers on top of a lovely JVM and the hardware just magically does stuff for you. It's all magic cloud. That's not true. Then we'll talk a little bit about how the JVM decides its ergonomics, a little bit about garbage collectors, because that's kind of the biggest, nastiest lever you need to lean on when you're talking about Java and containers, and then a little bit about how Kubernetes actually works under the hood, as best as I understand it. So let's talk about Java at Microsoft and why we care. So we actually have over 2 million JVMs in production. And this is for Microsoft itself. This is not for third-party customers bringing Java workloads to Azure. Right? This is us using Java internally. So when I arrived about 2.5 years ago after my company got acquired and I started mapping out all of Java at Microsoft, stuff just kept popping out of the woodwork. Right? There's the obvious Minecraft. LinkedIn, for those who don't know, runs about 300,000 JVMs to put up your lovely picture profile and allow you to talk to all of your friends in a business context. And the list just goes on. Azure Big Data. If you love your big Apache projects, that tends to run lots and lots of JVMs. So your Kafkas and Sparks and Airflows and NiFis and Accumulos. Does anyone know how many big data projects Apache now has? It's really confusing. I think there's over 10 of them. I don't know what they're trying to do. It's a little bit like Pokemon. Trying to catch them all. So that's why we care. So we run millions of JVMs. And because we're a cloud vendor, some of that stuff we run on VMs, right? VMs are perfectly fine. But a lot of it we run on containers. And so we then look at Java and go, is Java really well suited for containers? And the answer is, it's getting better. I'll dig into that. The other thing we care about deeply, well, at least Microsoft does, I just want to watch the world burn personally as a diabolical developer, but that's just me. Cloud compute is hands down the biggest energy leech on the planet, just about. It's I think it's like number 4 or 5 if you counted it as a country in terms of all the big data centers around the world, right? And so at Microsoft, we pledged that we would go carbon negative by 2030, I think the date is. So I've got a mandate from my VP chain which says, hey, you'd better start making that Java far more efficient the way we run it here at Microsoft, because right now we're burning lots and lots of energy that we shouldn't need to be burning. And I think that's very fair. So it's something we care deeply about, and that's my other driver for why we look at this stuff. All right, that hopefully gives you some motivation. And now we'll get on to hardware resources and how cloud compute really works under the hood. Now, of course, there's lots of clouds you can choose from. You see, I have a marketing team now. It's great. Anywho, they'll be pleased I put up that slide. So this is what a data center actually looks like on the inside, at least a little snippet of it. This is actually from an Azure data center. Look at all the shiny blue lights. It's pretty, isn't it? So it really is science fiction inside these places. They're utterly amazing how they work. There's probably, you'll find far better talks than I can give on exactly how these data centers work. But if you ever get the chance to do a public tour of, say, a Google, Amazon, or a Microsoft data center, do take up the chance. It is just a wondrous piece of futuristic technology. The cables are all color-coded really nicely if you're a little bit OCD like me. And it's very pretty to look at. But as I stated up there, you're still getting bare metal resource, right? Every one of those blades still has a limited amount of CPU, a limited amount of memory, and a little limited amount of hard disk and networking capacity. So please don't forget this. So this is a semi-typical cloud stack, right? There's actually lots of variations on this, so don't take this as gospel. This isn't necessarily the way that Azure services everything as an example, but this is the stack you're dealing with. And the challenge here is that at the bottom you've got the bare metal. That's the actual thing that says I've got 8 gigs of RAM, as an example, or actually we're in the modern age now. Let's say it's 128 gigs of RAM. Who needs 8? Who needs 8 gig? Boo. On top of that, you typically have a host operating system. More often than not, it's a very thin layer of Linux of some description. On top of that, you have some sort of a hypervisor. What a hypervisor does is it allows you to manage and create VMs. And whenever you go to AWS or Azure or Google Cloud and you say, I want to purchase a 8 gig of RAM, 2 virtual CPU VM, it's a hypervisor that's serving one of those things up to you. On top of that, you go and install your operating system. Again, typically Linux. If you come to Azure, of course we offer you Windows, because why not? We're also a .NET company. And if you're really container pro, you'll have some sort of a container engine and then containers on top of that. In computer science, we can always solve problems with another layer of abstraction. 1, 2, 3, 4. Oh, there's your JVM. And guess what? Your JVM is yet another virtual machine for your code to go run on top of. So the challenge here is that at every one of these layers, it's taking away that bare metal resource, right? So every layer on top of that is just adding a little bit of overhead, taking a little bit of that RAM, a little bit of that CPU. And so the thing that your JVM actually has at the top of that is not what it thinks it gets down all the way down at the bottom, right? So that's a key thing to remember. Okay. So this is me explaining in text what I showed in the picture, so I'll let people read that for themselves for a few seconds, and then we will move on. A slightly more common, or increasingly common layout is this. They're actually doing away with VMs and hypervisors and the host operating layer, because in container pro land, you don't need any of that, you just need to surface containers, right? And so here, you still have that very thin host operating system, then just purely a container engine, no hypervisors or things involved. So the key thing for you to remember is when you go in, let's say, purchase your cloud compute, you need to understand which one of these stacks you are getting. Right? So dig into the detail under the hood. There's always some technical documentation saying, hey, you're being served up a container out of a container engine, or you're coming out of a VM, whatever the case might be. So you have a better understanding of how much of that bare metal is being used up by all these virtualization layers below you. All right, and I talked about that already. It's good. So, what's the challenge here? The challenge is that a lot of software engineers and people who are in DevOps teams or SREs, they've forgotten how to count. And so they do things like this. They're like, haha, we have a 64 gig of RAM box. I will therefore allocate 16 times 8 gigabyte VMs, and the hypervisor will just magic physics out of nowhere, and magic RAM will just appear. And of course, if all of the VMs are using all of the RAM, right, that doesn't fit. It doesn't work. And so all of a sudden, the host operating system under the hood is having to page memory in and out of the hard disk instead of actual physical RAM, because you've gone and over-allocated all these VMs on top of a piece of bare metal. Now, modern hypervisors are super clever, and they shunt stuff back and forth really, really quickly, and sometimes you get away with it. But please, when you look at what you are allocating in your own data centers in particular, just make sure you do the basic arithmetic, right? Make sure that the number of VMs or the size of the containers that you're mapping on top of the actual bare metal machine, that the maths actually works out. We've had some really fun conversations with customers on that one, as they get very confused why their cloud compute is so slow, as they throw 128 containers on a single VM. It doesn't work. All right, so let's talk a little bit about the actual topic at hand here, JVM ergonomics. Love this slide. And so a lot of people still do the traditional, I will bash out their code on my laptop and it performs fine, and the JVM ergonomics will allocate a certain amount of heap and will allocate a certain garbage collector and stuff based on me running on my laptop. Your laptop is not the container you are deploying to. More often than not, people are trying to deploy to containers which are far more resource constrained than the lovely Apple or Wintel laptop or desktop that you may be using. It's a very common mistake. We see it time and time again, especially when people shift and lift their workloads from on-premise onto cloud, and they go, we're going to move it from our big bare metal iron system, and we're going to shove it all into containers on the cloud because containers are cool. That's what the cool kids are using. And then they don't realize that their giant, typical 16 gig heap application doesn't squish into a 1 gigabyte container very well. All right, so we have a blank slide for reasons. And we asked some questions on Twitter. So my product management peer, Bruno Borges, I highly recommend you follow him and ask him about his favorite topic, YAML. So we all love YAML. So we asked some questions. How many garbage collectors are available on a typical OpenJDK distribution? Yeah. And the answer is, indeed, there is more than 4. But notice that half of your colleagues, right, half of the Java industry thinks otherwise. Uh-oh. We're already starting to see some problems here. Next one. Do you expect the JVM to pick the right ergonomics for the garbage collector, and based on what? Most people got this right. It is actually based on CPU and memory available. So that was pretty good. So people kind of understand the JVM does that for you. That's good. Next one. How many garbage collectors do you think the JVM may consider? Who thinks it is all of them? 1 person? 2 people? Who thinks it's 2 of them? Who thinks it's 3? Who doesn't know? Wow. Wow. Okay. See, this is the whole motivation for me giving this talk. So the answer is, it only selects between 2. But notice up above, there are actually more than 4 available to you. So if you think the JVM is magically going to pick the right garbage collector for you, you are wrong. So don't let the JVM pick anything for you. And I'm going to repeat that advice time and time again. You need to go do this yourself in containers. Right. Do you trust the JVM? Yes, until, I love the yes until now. It's like, I did trust it until you asked me this question on Twitter, and now I'm scared. So again, 43% of you trust the JVM when you should not be. And previous to that, it was actually more like 60-odd% until the survey came out. So that's, again, quite concerning. All right. And last, would you like better JVM ergonomics? So despite the fact that people trust it, they want it to be better. There's some sort of cognitive dissonance going on here. I'm not quite sure what is happening, but there you go. All right, how are we doing for time? On slide 18, we're 14 minutes in. Winning. My idea here is to just keep talking about all the non-technical stuff because I'm a manager and hope you don't notice. I'll get about that. Right. Then another little summary, another little survey we did, 150 people. Most developers are deploying containers with up to 4 CPUs, about 2/3 of you, up to 4 gig of RAM, about 2/3, and they are considered to be I/O intensive because we write big Java apps that shunt lots of XML and JSON around, don't we? Who here writes a Java app that converts XML to Java and Java back to XML again? Who does that to JSON? Who does it with their own proprietary data format? No one here from, oh, 1 person from investment banking, yes. Love it, good. All right, so we did some more surveys. So we actually call this, in Microsoft we call this customer development. That's what our product managers actually go and do. They go out and just keep talking to people and sending out fun Twitter surveys until we get the answer that we want. But this survey was actually from our good friends New Relic, who are a partner on Azure, they're one of our APM partners. And they recently released some public research with over 10 million JVMs worth of data. It is skewed because this is skewed towards New Relic customers, and they're their own special breed. They tend to build. New Relic is dare I say, a newer company as far as APM vendors are concerned, and so you really are talking about a cohort which are generally more cloud native, pro, a little bit more container, 12-factor apps. They deploy to cloud, that kind of thing. So a majority of people are only deploying with one CPU or one virtual CPU. Isn't it interesting? Who here thinks that Java might like more than one CPU when it's doing its stuff? Yeah, exactly. Do we all see a problem here? It's math again. Oh dear. All right. So, majority also a gig or less of RAM. Now I'm looking at the average age of the audience, and no offense, but I suspect most of you have been in Java long enough where deploying any Java application with less than 4 gig of RAM is you just don't do it, right? Big on-premise monolithic applications, just keep doubling that RAM, 8, 16, 32, 64 gig heaps. We love it. Now in container world, we're trying to shove it into 1 or less. Oh dear, not good. So there's lots of ways we can try and fix this. We either increase the heap, which means you need to increase the size of your containers, which means you spend more money with Microsoft, and we're very happy. But in reality, that's actually not what we want, right? Nobody actually wants that. It's terribly inefficient. It costs the world energy and climate change and all that badness. And you actually grow to not love Microsoft because you don't trust and like the fact that we have to run big fat Java in containers. We don't do a good job for you. You can scale out if you're pro, or you can migrate to another stack. And so you see in the tech media every once in a while saying, Java is dead, big company X is going to rewrite everything in Go. You just have to ask Netscape Navigator how their rewrite went and how much market dominance they have today. Oops. So these big rewrites, it's just not possible, right? You tend to have to stick with your tech stack if you're a big company. All right, so this is the real fun part. This is the bit where you actually have to start paying attention. So with the hotspot JVM or OpenJDK, doesn't matter which vendor you use, so that could be Oracle JDK, Red Hat's OpenJDK, that'll come with your Red Hat like Linux subscription typically, Azul Zulu, Eclipse Adoptium, Microsoft build of OpenJDK. Yes, we have one. Isn't that cool? If you're Java 11 or later, it will select between only 2 of the GCs. One is a serial collector, and one is G1GC. No ZGC or Shenandoah or Parallel or CMS is in that list to be auto-selected, even though they could be the best choice for you. If it's Java 8, and this is where I ask the name and shame question, who here is still on Java 8? Everybody look at these people and say, shame, 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 shame. You must get off Java 8, please. For us, the whole industry, where it's choking us, literally. If you need some help convincing your bosses to move from Java 8 to Java 11, feel free to contact me. I have lots of business reasons. Remember, I'm a manager of managers, so I deal with dollars and spreadsheets and business cases. And we will help. And Microsoft has actually written some public guidance as to reasons to move from 8 to 11, including some business reasons to do it. And it's up in our Microsoft docs, as well as a technical guide on how to do it. So I'm mainly going to talk about 11, because I'm sorry, 8's people, we're just going to leave you far behind. Actually, I do want to check one more thing. Let's see if we can beat Sweden. Who here is on Java 17? Ooh, you're about equal with Sweden. Okay. I'm doing an international competition. The Americans, not good. Not good. They don't know how to count to 17, apparently. So, if the JVM ergonomics detects that it is running a heap of less than 1,791 meg, don't ask me why they picked that specific number. Maybe one of my engineers can tell you. It will pick the serial garbage collector for you, automatically. That's what you get. Otherwise, you get G1GC. Simples. So that's not too complicated. All right, let's see what that might actually do to us. Here's a little bit of JVM ergonomics demo, and I could try to live demo this, but I'm a manager, so instead I took screenshots. There's a tiny little application there which tells you how many active processes you have, and you can use that inside your container so that your JVM will tell you how many processes the container is giving it, not how many processes the host operating system has. Right? That's a key difference. So Java, even Java 8, the latest versions of Java 8, will detect this correctly. What the container is giving you, not the host operating system. And that lovely little bit of shell script there is basically Docker going off to Microsoft's container registry, grabbing down a Ubuntu container with Java 17 in it, running Java and the very cool flag there of -xx print flags final, which will print out all of the hidden configuration that the JVM has implicitly set, including by its ergonomics. It prints out something like 300 flags. It's a really long list. And then I use grep because I'm Linux Pro. And we grep for which GC do we use. And as you can see here, it's going to use the serial GC. And the reason is because I set the memory to be 1500 meg. And remember that 1791 number? So serial is automatically going to get selected. If I have time at the end of the talk, I'll try and live do that code demo using Visual Studio Code and using GitHub Copilot AI to write the code for me because I'm a manager. Brilliant. So let's talk about the garbage collectors. There is actually what I would say to be 5 relevant garbage collectors today between Java 11 and 17. And here is some advice that we at Microsoft give to our customers about which one you might want to start with. Okay. And this is advice, this is not prescriptive, this is not always 100% accurate for your application, so you need to test these things yourself. But sort of going from left to right, you're really starting from small heaps, small amount of CPUs, right? And as you go across to the right, you're talking about much larger heaps, and you typically need more CPUs to run. And the reason is that the garbage collectors on the right-hand side are what we call concurrent garbage collectors. So they let your application keep working while they're tidying up under the hood for you, behind the scenes. And they do that in parallel, or with a bunch of concurrent threads. ZGC and Shenandoah in particular, ZGC is primarily run by Oracle, Shenandoah primarily run by Red Hat with some help from, I believe, AWS these days. They are the two kind of, I would say, future garbage collectors that are going to sort of compete against each other going forwards. But again, they kind of always have garbage collection happening under the hood. And the reason why they're designed that way is to stop those latency spikes. So everyone knows that garbage collectors make you pause the JVM, yeah? And your users scream at you because like all of their requests just pause for a second or two. So those modern garbage collectors try to avoid that. That's their goal. So there's some guidance for you. If you are going to run really large heaps and you've got lots of CPUs, you can start using the ones on the right. If you're more resource constrained, you need to start looking carefully at the ones on the left. Notice parallel, very useful GC in certain circumstances, is never automatically selected for you by the JVM. That's a concern. All right. So because I work for Microsoft and I really love PowerPoint and I love lots of bullets, I put as many bullets as I could on this slide. The bottom right-hand corner is the bit that you really want to pay attention to. So you can't just go and start your JVM in a container especially and just say, I'm going to set the heap size, the JVM will take care of everything else, right? You've really got to understand what your workload is. So if we go back to here, you see the best for line there really talks about kind of, batch jobs are really useful for parallel as an example. If you want a certain type of responsiveness, you might need to look at some other ones to the right-hand side. So you've got to understand your workload. You've got to make sure you've got enough CPUs to run the appropriate garbage collector. If you only have a single virtual CPU or a single CPU, it is going to struggle to effectively run things like G1GC, Shenandoah, or ZGC, right? Because those garbage collectors constantly need active threads working behind the scenes, okay? And that's constantly going to be tying up at least a portion of the time on that CPU. So you want to have a second CPU core, usually. And if you remember all the way back to that New Relic data, most people are deploying to containers with only one virtual CPU, right? So those garbage collectors won't work well on them. All right. So in terms of heap size, this is what the JVM does. If you are inside a container, by default, if you don't set it explicitly, it'll give you a quarter of the memory of the container, which is reasonably safe, but it's super conservative, right? I mean, the container, unless you're running something which uses up a lot of native memory in that container as well, that's just a waste of memory, effectively. Outside a container, so on your laptop or on a server, it's 1/64th, which is even smaller. So, when you're dealing with containers, our recommendation, and again, you need to check your application and check the type of application you have, is that you want to start at 75% of the memory that your container makes available to you. And you can set that in two ways. You can either set it via minus XMX if you know your container is going to be a certain size and a certain size always. But if you're a little bit more dynamic about your containers, especially if you're using something like Kubernetes, which might spin up certain size containers for you, etc., depending on the demand, we would recommend using the minus XX max RAM percentage and set that to 75. So that gives 25% of memory left in the container for things like Java's actual native memory usage, which it does need room for. Anything that your application might be using native memory for, like, I don't know, gRPC connections, database connections, that sort of stuff. And don't forget, the container is still running a thin layer of an operating system, right? You're still typically running some sort of a Linux, so to speak, inside your container. That needs native memory as well. So never ever allocate 100% of your JVM heap size to be the same size as the container. Okay, that should be a big no-no. If you start to run much larger containers, you can start to increase that percentage because the overhead doesn't necessarily scale. So if you're running, I would argue, anything that's 8 gig or above, you can probably start setting it to be, say, 80% or maybe even 85%, and just monitor your application and see how it goes. All right, so that's a good starting point. This is a quote from Monica. I'll let you read that. She gives lots of really great talks, so you might want to take a photo of that. Just look her up on InfoQ, infoq.com. There's a whole bunch of talks she gives there about the true inner workings of these garbage collectors. You'll find that helpful. This is pretty much summarizing the same information. So again, if you need to take a photo of that, that's fine. Notice their parallel GC in general outperforms G1 GC for smaller heaps. And if you remember, the JVM only selects serial or G1 GC as the two ergonomic defaults. So you have to set parallel explicitly. All right. Let's talk about something that Java doesn't do so well. Let's talk about Kubernetes. Who here is now running Kubernetes? Who here likes it? There are 5 system administrators sitting in the back. So I was going to do a demo about Java and Kubernetes and show you on the command line how to spin up a whole bunch of pods and stuff. And so I thought to myself, how hard can it be? I then took a look at the basic Kubernetes commands. And I thought to myself, no. This is why we have things like the Azure Kubernetes service. This is why we have things like Red Hat's OpenShift, stuff to make life actually sane for you as a developer trying to deploy to this thing. Some would say Kubernetes is a very rude word in Klingon, which I won't say because I did say that in my last talk and I nearly got fired. So after doing a lot of this and learning about how Java really runs in Kubernetes, I found out some lovely useful information for you good folk. And this is how Kubernetes actually does CPU stuff. I've talked a lot about virtual CPUs or a single CPU core, and the JVM will pick up on that particular fact. What Kubernetes actually does is it doesn't give you a single virtual CPU. It gives you a time slice of a CPU. And I got caught out by this the first time I used Kubernetes, so I'll try and walk through it. And it talks a lot about, you'll hear the phrase millicores, and most of you here are using Kubernetes, so hopefully none of this is terribly new to you. And so 1,000 millicores doesn't actually necessarily mean it's a whole virtual CPU. It just means that's the amount of time slice you get. But the way the JVM interprets that is it goes, if I see about 1,000 millicores, I'm going to call that one CPU as far as my ergonomics is concerned. If I see between 1,000 and 2,000, I'm going to call that 2, and so on and so forth. So Java doesn't really natively yet deal with the concept of millicores as such, right? It kind of tries to convert it to what it understands as being processors. I suspect this will change in modern versions of Java coming out, especially with things like Loom and other technologies coming into the JVM. So there is hope. I've already seen a massive thread start on Java 19 on this, so that could be quite cool. All right. Now, you have to remember that for this time slice, that if your threads use more than what you've got allocated, Kubernetes starts throttling, right? And Java applications, of course, are multi-threaded, right? Constantly doing stuff in the background. JIT compilation, garbage collection. Most of you have got a ton of database connections, that kind of thing, right? So lots of threads doing lots of work, not just your business logic churning away. So, again, I'm extremely lucky that I've got a product manager peer who can pull together really cool slides with animations. So we could say ooh and ah a lot. Woohoo! Yes! The power of PowerPoint. Love it. Right, so those were 4 HTTP requests, and each of those virtual CPUs was kind of serving that up. And each of those requests, let's say it took 200 millicores of CPU time slice as far as Kubernetes is concerned. So 4 times 200 is 800, which leaves us with 200 millicores, right? And remember, we're assuming that we're starting with the CPU limit of 1,000. That's what we set in our Kubernetes configuration. So then some GC threads actually also do some work, right? And they use up the remaining 200 millicores. And how much do we have left? None. And so what happens when the last 2 HTTP requests come in? Kubernetes says no. I'm not going to throttle you. That's not going to go in. And you have to wait for another 60 millicores or 60 milliseconds until the completely fair scheduler, which is the most confidently named piece of software I've ever run across, well done to that engineer, will then actually allow those HTTP requests to come through. So you have to be really careful and understand that Java as a managed runtime does all this extra work under the hood, not just your application threads. So you can't just count the time that you think your business requests coming in. You have to think of all the underlying stuff as well. Okay? All right. Now remember, the JVM, I said this before, it will try and map millicores to what it thinks a processor is. So, if you only give it 1,000 millicores, it only thinks it's got one processor. You remember all the way back to when we were talking about garbage collectors that typically need more than 2 virtual CPUs to run efficiently? Right? Therein lies the challenge. So, if you've only got 1,000 millicores, you need to think very carefully about tricking the JVM into thinking it's got more CPUs so that the certain garbage collectors can actually run more efficiently. And to do that, you say -XX active processor count. And you just tell the JVM it has as many CPUs as you're willing to lie about, which is great. And it goes, okay, thank you, developer. I will have those 32 CPUs that just don't actually exist, but I'll carry on. I'll dig into that a little bit more. So here are some starting points that we recommend to all of our internal teams at Microsoft. And again, these are just starting points. So you have to think about your workload, your application, all those things. This is not prescriptive advice. It's just a starting point. If you've got less than 1,000 millicores, the JVM will think you've only got 1 CPU. So you need to tell it that it's actually got 2, right? Because remember, you're being given a time slice of a CPU here. So it's kind of actually okay to lie in this particular instance. If you've got a really small JVM heap in your container, set the heap size to be about 75% of the container size. And you can increase that percentage as your heap gets bigger. So if you're really talking about 0.5 terabyte heaps, for example, you can probably get away with like 80, 85% heap size. Unless you're using one of those crazy Apache projects that actually does all of its work in native off-heap memory. Then you've got to be really careful. As an aside, Java does have a flag for native memory tracking. So when the JVM goes and writes out to native memory, there is a flag that tracks that. I forget what it is, and I forgot to put it on the slide, so you can come and see me afterwards, and we'll do some Googling, or some Binging, sorry, because I work for Microsoft. We use Bing. Got to remember that. I'll get in trouble. So hopefully this pathway helps you with when you start working with containers and Kubernetes as a starting point, and you just have to measure and see how your app responds to that. Ooh, lots of time left. All right. This benchmark slide I get confused about by myself, so I'm just going to skip past it. Then we're going to talk about how you deploy on cloud or in containers. Do you deploy lots of JVMs in a container and try and have lots and lots of virtual machines, so short but wide, as we like to call it? Or should you go tall and narrow, right? So have even more JVMs and virtual CPUs, but in a single virtual machine. So here we have an example in Azure, because it's our favorite cloud, of course. We even have the dollar estimate here for you, because that was my budget, and my engineers love spending my budget, and I love explaining that to finance. It's great. So here we have a case where we've got 6 VMs, and the total resources consumed, there is like 18 JVMs, which are the replicas, there's 18 virtual CPUs being used, and about 36 gig of RAM being utilized. Out of the 96 that's actually available, right? So we're wasting stuff here. The garbage collector, interestingly selected by the ergonomics, is going to be the serial GC. And what else do I need to say about this? There's going to be lots of, so the side effect of this is that there's going to be lots of stop the world garbage collection going on, because that's what happens with the serial GC. When it really needs to clean up, it just stops your JVM and says, nope, I'm busy cleaning. All right. Alternatively, for the same low cost, and we did actually cost this out, so I won't say this is true for every competitor cloud out there, but certainly the way Azure's pricing works, this is actually a like-for-like match, and it was deliberately designed this way. You could stack a whole bunch of virtual CPUs, nice and tall, on a smaller amount of VMs, and you can see here that the total resources that are consumed is only 12 virtual CPUs. Only 24 gig of RAM is actually used now, and you get the G1 GC as a default garbage collector. So it's going to be a totally different experience in terms of the default performance of your application, just by rearranging the way you deploy on the cloud. So it's something that you need to think about. And so that's how much savings you've got. You've got a whole bunch of virtual CPUs and a whole bunch of RAM ready and usable for you as you need if you need to dynamically scale, right? Much more than in the opposite way of doing it. So basically what I'm trying to tell you is that with JVMs in particular, because they're in these managed runtimes, and because Java isn't quite there yet in terms of being packed down to the smallest size possible and understanding Kubernetes millicores and things, you might want to consider this style of deploying your Java applications as opposed to the short but wide style for your Java applications. Again, it will depend on what your app does. If you are doing a greenfield application and everything is microservices pro, then this is actually going to be fine because you've deliberately designed it for this model. But if you're lifting and shifting, which is what most of you are doing at the start of your journeys, then this model may be more appropriate for you. All right. So yeah, that's just talking about the two topologies. So topology number A, which was that first one I showed you, lots of small JVMs, lots of replicas going out, and then the other topology going the other way. All right. So, as a summary, to address your performance issues that you might be having, understand the tech stack that you're actually on. So really do go look at what we call the stock keeping unit, the SKU of the thing that you're buying off your cloud vendor. Understand about the JVM ergonomics, right? So I showed you a whole bunch of numbers and slides and defaults that happen. Never ever let the JVM select for you. You should always tell it how many processes you want, how much memory you want, and which garbage collector you want. Okay, that's super important. What else do I need to say? You should observe and analyze the results of this, of course. So we say measure, don't guess. Right? We try to be data-driven. And there's a whole bunch of free tooling out there that can help. On Azure, of course, we have Azure App Insights, New Relic as a partner, so on and so forth. You'll find your own on whichever cloud you're on. You can also look at stuff for yourself for free. So Java itself comes with this cool technology called JDK Flight Recorder, or Java Flight Recorder as it's known, JFR. And there's a whole bunch of streaming libraries, one from Red Hat, one from New Relic, one from ourselves, that you can stream that data out off the disk, right, off to somewhere where you can go and analyze it. There's a free tool called Java Mission Control, which you can download and use to analyze all that flight recording data and understand what the GC is doing. We also recently released on GitHub, so you can go to github.com/Microsoft/GC Toolkit, a library that reads GC logs, parses them all, and puts them into a model of the Java memory model. And you can actually start to build analytics off the back of that and understand what's happening with the memory in containers. Then you want to have a look at reorganizing your existing resources, so that short, wide, that tall, narrow. You might want to look at those options. But again, I think the really key takeaway here is, because I've told you lots of different things, is just make sure you always explicitly tell the JVM what you want. Don't let it select for you. And always remember that garbage collectors, especially G1, GC, and the ones to the right, they typically want more than one CPU to operate with. Okay, that's two critical things. So that's the conclusion. Depending on your workload, you should think about the topology, so not one size fits all in how you deploy. Give more resources to JVMs if possible. Right? They're still designed to be slightly larger, heavier weight than, say, a tiny bit of C or C++ as an example. If you have a small heap, we would actually recommend trying for the parallel GC first, especially if you can tell your JVM that you've got at least 2 of those virtual CPUs. And then definitely please do start looking at the Java flight recorder data or GC logs, that kind of stuff. Don't rely on your SREs or others who may not understand Java as well as you to go do that. All right. If you really want to know more in depth, like the actual technical detail behind all this stuff, that first link up there is the 2nd edition. My name is on there for vanity purposes only. I actually only wrote like the introduction to chapter 12, which is a chapter on containers and Kubernetes and things. Jason Clark actually finished it for me because he's an engineer. And we at Microsoft, all what I just told you today is all publicly up on our docs. And so it's there for the whole world to share. And as we change our minds on things, or as we get more data, we will be live updating that doc with more guidance as time goes by. So you will always know it's up to date. Last but not least, if you want to follow what we're doing at Microsoft, and we're going to continue to push out engineering content like this on our blogs and that kind of stuff, you can follow us on Twitter at Java at Microsoft. And if you get the number of followers up by a couple of hundred, I meet one of my OKRs and my boss is happy with me. So I'd really appreciate it. Again, that is our portal for all things that are related to Java at Microsoft. So if you go to docs.microsoft.com/Java, you can learn about our build of OpenJDK, Visual Studio Code for Java, what GitHub is doing with Java, so on and so forth. Everything you need to know. And that cool QR code is for the competition we're running down at the booth, where you can win shiny Microsoft gear, like from our hardware division. So that's very cool. Thank you very much for your attention and time. I'm very happy to try and do a demo the next time I see you all, or come down to the booth and I'll actually show you that live Visual Studio Code GitHub Copilot thing. And yeah, I hope you learned something useful today. Thank you.